Hello, everyone. Welcome to today's webinar. We use features with feature view on Hopsworks. I'm Kenneth, and I'm a software engineer in Hopsworks, and I'm working on the feature store team. Today, we will talk about an example of machine learning system and some challenges in machine learning systems. We also talk about how feature views or in general feature store can solve these challenges. And I will show you some code about how you can use feature view. So first, let's look at an example. So here is an example in Visa, the credit card company. In general, machine learning system can be classified into two different types. One is online serving types, and the other one is the batch serving type. In online serving, where we need to handle requests from clients in real time and also produce a response in real time. In the batch serving system, we just need to run a job in a specific time point regularly and create some sort of output in the form of database. So let's take this fraud classification system as an online serving example. So in this system, we want to classify a transaction if it's a fraud or not. The way we do it is we want to compare the transaction in the past and the current transaction. So to start with, we need to create a training data set. We have a training pipeline to extract features from the data warehouse and create a training data set. So in this example, in the data warehouse, we have user ID, we have the transaction date and transaction amount. And in the feature training pipeline, we aggregate the transaction amount and create two features, which is the transaction amount last week and transaction amount last month. And then we will use this training data set to train our model. Once the model is done, we need to put this model into production. So we have another feature pipeline in production, which will extract new data from the data warehouse and create the same set of features we have as in the training pipeline. And then in the online serving part, we will receive requests and then fetch features from the database and apply the models and generate a response, which is the fraud label. In the batch serving example, we can take a look into a user categorization system, which try to categorize user into different group based on the transaction amount in the past. So so that one use case is the marketing team can send appropriate marketing campaign to the user based on the user category. So similar to the online serving example, we will have a training pipeline to create training data set and train the model. And we will have a feature pipeline to in production to extract new features or new to extract a feature from the new coming data. But the difference is now we do not need to handle real-time requests. What we do is we run this job, for example, daily, and create a database which store the user ID and also the user category. So next, I will talk about some challenges in the system. First of all, as you can see, the same set of features, in this case, transaction amount last week and transaction amount last month, are generated in multiple pipelines. And it is it increased the development and maintenance costs. As you know, this pipeline or the machine learning models are changing all the times because we always want to improve the accuracy or the performance of the models. So we always want to modify the existing features or adding new features to the models, which means that in this case, if you want to add a new features to both systems, we need to modify 4 pipelines, which is really time consuming and also a waste of resources. Or if we found a bug in one of the pipeline, we need to modify all the pipelines to resolve the bug. And this system is also not scalable because, for example, if we have a new system which try to use the same features as we have before, still we need to create a new training pipeline and also a new feature pipeline for the new system, even though we already have the features before. And since we are calculating the new features in production all the time, these features are computed multiple times, like every day in production system, which is also a waste of resources and also a waste of storage space. So another challenge is that the same features generate from the training pipeline and the feature pipeline can be different. It is quite common that the training pipeline and feature pipeline are maintained by a different person. For example, a training pipeline is usually written by data scientists, where they developed models. And the feature pipelines is usually written by machine learning engineer or data engineer. They want to fetch new data from the data warehouse regularly. And these 2 pipelines can even be written in different languages. For example, data scientists want to use Python, and machine learning engineer want to use Java, for example. And there are many different cases where results which result in different features in these 2 pipelines. For example, a data scientist can extract features transaction amount last week by aggregating the transaction in the past 7 days, while a machine learning engineer can aggregate the transaction from the last Monday to last Sunday instead of the past 7 days. So which will result in different feature values. Also, the way we handle the null value can also be different in the two pipelines. And most importantly, when there's transformation or normalization in the features, which may require some parameters, for example, mean and standard deviation. And if a data scientist do not save or pass this parameter to the machine engineer properly, they can result in different transformation in training and in production serving, which will lead to the problem of training serving skew, and it will hurt the model performance significantly. So next, I will talk about feature view and how it solved the challenges. So feature view, or in general feature store, can solve the above challenges. Feature view it works hand in hand with feature groups. A feature groups is a list of features in a table, and we can ingest the features from feature pipelines. And feature pipelines can be a streaming pipeline, for example, in the form of a Spark streaming, or a batch pipeline in the form of a Panda data frame or a Spark data frame. And feature view is a interface of the features from the feature groups. And we can create a feature view by joining features from feature groups. So this feature view is an API for machine learning model development and operation. And we can define features which exist in the feature group, labels, and also transformation in the feature view. And we can get feature vectors using the online API, and also get training data set and batch data using the offline API. So let's see how feature view can solve the challenge in detail. So before, we have multiple pipelines generating the same features. Now we just have a single pipeline which ingests data from the data warehouse to feature groups. And once we have the data or have the features in the feature groups, it can be read multiple times by many feature views, and then we can generate training data sets or production feature set later on. And so now, if you found a bug in one of the in the feature pipelines, you just need to modify one feature pipelines instead of all the feature pipelines in different systems. Or if you want to add new features to the systems, what you can do is you just need to add the features in this feature pipeline, and then it can apply to all the system. Or you can create a new feature pipelines and the new feature groups, and then feature view can read the new features from the new feature group and apply later on. And it is also easy to scale to new system if the new system want to use the same features we have in the feature groups, so that we do not need to like reinvent a new feature pipelines for the new systems. So in this case, before the same features are generated from different pipelines for training and for the production features. Now we have the single interface, the feature view, which read features from the feature groups and apply normalization or transformation to the production or the training data set. So you can see now the features read consistently and apply and the transformation is applied consistently in both cases. It is important to note that the transformation is applied in the feature view instead of in the feature groups. It is because we do not want to save multiple feature groups of the same feature definition. So now we can look at a demo. In this example, I want to show you a credit card fraud example and show you how you can create a feature group and ingest data to the feature group using a feature pipeline, and how you can create feature view and by reading data from the feature groups. You can find this demo in the GitHub repository, logical close Hopsworks tutorial, and you can run this demo in Colab here. Because yeah, it takes time to run the whole notebook, so I have already run it and have the results ready. So first of all, in the first notebook, we want to create a feature group and ingest data to the feature group. So here we have some raw data. We have three data source. First one is the credit card data set, which have the credit card number and some credit card information. And we have another data set called the profile, which have the demographic information of the credit card holder. And we also have a data set called transaction, which will store the transaction detail of each credit card. So then we will perform some feature engineerings on these three data source by joining them and aggregating some of the column to create some features. So I do not go into detail about how we create the features because it is different in different example. But now, once we have done the feature engineering, we will create a feature group. And to create a feature group, we just call this get or create feature group in the feature store, and we specify the name and the version of a feature group. And also we can also add some description to the feature group. And then we can ingest data to the feature group by calling the insert method and passing the data frame we had after the feature engineering. Then we will have a feature group which have this list of features. For example, the category, the city, the age, etc. In this example, we also create another feature group which store some aggregated statistic about the transaction volume. For example, this transaction volume moving average, or this moving standard deviation of transaction volume from the credit card. So next, we will see how to create a feature view. So first of all, we get back the feature groups we created before. We have two feature groups. And then we will select some features from feature group 1. In this case, we want to get the age and also the days. And then we will join the first feature group to the second feature group. And in the second feature group, we want to select all the features except the credit card number. So now we basically have defined a set of features which will be used for model training. And we call this set of features a query in Hopsworks. Now we go ahead and define the transformation function for each features. You can define your own transformation function, but we also provide some standard transformation functions. For example, this min-max scalar and also the label encoder. And since this category is a categorical features, we apply the label encoder to convert the string to integer, basically. And we apply min-max scalar to rest of the features. So now we can create a feature view by calling this method. We defined a name and a version of a feature view, and we defined the query we have specified before, and the label, and also the transformation function. Once we have a feature view, we want to get a training data set from the feature view. So here we try to get a training data set with 3 different splits, the training, validation, and test splits. And we can define the size of different split like this. And we can also define the data format. In this case, we want to create a training data set in the CSV format. So once you run this, you will get a CSV file. So next, we will apply this training dataset and train the model. So the way we get the training dataset back is like this. So we get back the feature view, and then we call this get train validation test split method to get back the training dataset. And here you can see it will read the CSV and then convert it back to a panda data frame. So you can see these features are the features we defined in the query, and the feature value has already been transformed. Then we can pass this training data set to train the model using logistic regression. And then once we have our model, we want to apply the model to new data, the new incoming data. To get new data, we can call this get batch data method. And it is also possible to specify the start time and end time in this method, so that you can always predict new incoming data using this method. And as you can see here, the batch data frame is the same as the training data set. You get back the same set of features, and also again the feature value has already been transformed. And yeah, and the transformation is done in the same fashion as in the training data set. And then yeah, and then you can like predict the fault label in this way, and you get back the fault label like this. So in the online surfing use case, you can get feature vectors like this, and then this by calling this, you will get back a feature vectors in like a millisecond. And again, this set of features are the same as we had defined before, and the value is transformed already. And then in your online application, you can predict the label of this request. So this is the end of the demo, and the end of my presentation. If you have any question, you can ask me here, or I encourage you to also join our Slack channel here and ask us any question in the channel. We also have more tutorials in the Slack channel, so please check that out also. Thank you.